Oh, I said so. Okay. The key is we look in the cardinal directions and then use symmetries that we know about, ellipses and parabolas and hyperbolas, to fill in other points. So, in the cardinal directions, 0, pi over 2, pi, and 3 pi over 2. R is, let's see, sine of 0 is 0, so we have 3. At pi over 2, sine is 1. 3 halves, 3 divided by 3 halves goes 2 times. At pi, we're back to 3. At 3 pi over 2, we're up to 6. Sine of 3 pi over 2 is negative 1. Negative 1 times a half is negative a half. 1 minus a half is a half. 3 divided by a half is 6. So in those directions, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 6. This is the focus. The ellipse, let's see, 3 there, 3 here, 2 there. So if the focus is 2 units from the vertex on that side, it's 2 units from the vertex on this side, and it'll be out 3 and out 3, and we'll connect these with a smooth curve through these points. And we get an ellipse which is slightly elongated in the y direction. So this is pi over 2 direction, 0 direction, pi direction, 3 pi over 2. That was 6, this is 3, that was 2, this is 3. Okay. And that's our sketch of the ellipse. Okay. Let's look at a parabola. R equals, let's keep the 3 there just because, 1 minus 1 times the cosine of theta. Okay. Again, in the cardinal directions, 0, pi over 2, pi, 3 pi over 2. When theta is 0, cosine is 1, 1 minus 1 is 0, 3 divided by 0 is really big. Okay. At pi over 2, cosine is 0, 1 minus 0 is 0, so we get 3. At pi, cosine pi is negative 1, 1 minus negative 1 is 2, 3 divided by 2 is 3 halves, and again at 3 pi over 2, cosine is 0, so we get 3 again. So, in those directions, let's see. In the direction of 0, we don't get anything. In the direction of pi over 2, we get 3. In the direction of minus pi over 2, or 3 pi over 2, we get 3. And in the other direction, we get 3 halves. And this is the vertex, the focus is there, this is the latus rectum, and the curve goes like so. 0, pi over 2, pi, 3 pi over 2, this was 3, this was 3, and this was 3 halves. And you see we have a parabola. Okay. Let's do a simple one. Let's do the circle. If I have R equals 5 over 1 plus 0 times anything, still following the pattern. This is simply R equals 5. 5, 5, 5, 5. I think I'll do this in degrees. You can do them in either degrees or radians. unions, it doesn't matter as long as you're consistent about your labeling. There we get a perfect circle of radius 5. So the one we haven't done is when E is greater than 1. Let's say R is equal to 3 over 1 minus twice the sine of theta. And again, in the cardinal directions, theta, R, when theta is 0 degrees, we get 3. When theta is 90 degrees, sine of theta is 1, so we have 1 minus 2 is negative 1. So at 90 degrees, we get negative 3. At 180 degrees, we're back to positive 3. And at 270 degrees, I think we're at 1. Sine of 270 is negative 1. Negative 1 times negative 2 is positive 2, plus 1 is 3. 3 over 3 is 1. So, sketching those, in the direction of 0, we have 3. In the direction of 90, we have negative 3. In the direction of 180, we have 3. In the direction of 270, we have 1. And this is a hyperbola. The way we get a hyperbola out of it is that the 2 points which are on the same side are actually the 2 vertices of your hyperbola. So one branch of the hyperbola takes in those 3 points. And the other branch of the hyperbola, by symmetry, if this is focus is 1 beyond that, and the focus is here, go out 3, go out 3, connect these, and we get our hyperbola, and the asymptotes will be somewhere in here. 0 degrees, 90 degrees, 180 degrees, 270 degrees, 3, 1, negative 3. So there are 4 conic sections based upon the one formula. R is some amplitude over 1 plus or minus E times the sine or the cosine of theta. And using sine, they tend to be oriented vertically. Using cosine, they tend to be oriented horizontally as far as the directions they go. But again, you can plot points. If you have a graphing calculator, you put your graphing calculator in polar coordinates, and it'll graph nicely.
Yeah, it does.
If you,
I tried it.
If you have it in rectangular coordinates, it doesn't look anything like this. Those are conic sections in polar coordinates. And I have here, that's the last thing you need to show if you have any.